Welcome back to another one of our instructional videos. This one I'm going to finish up systems of equations, and we're just going to take what we already know how to do and we're going to progress and apply it to either linear quadratic situations or quadratic systems. Now just to go back to the visual, when we did the linear ones, the 2 by 2 in particular, we looked at graphing lines and where they intersected. Well, if you're a visual person, let's just think about what might happen. If I have a linear, meaning a line, and a quadratic, a parabola, and I try and determine where they intersect. Well, there's three different things that could happen. They may never intersect, so don't be alarmed if you try to solve one of these and you get no solution. They may only intersect once. They call this a tangent line, so it just touches that graph in one spot. Or they may cross each other twice and you get 2 points of intersection, so you have two solutions. Now likewise, we're also going to do quadratic systems, so two equations, both being quadratic, and trying to determine where they may intersect each other. Well, this could happen. They may never intersect. This could also happen. This would be a way they'd never intersect. Let's say the one on the inside had a narrower stretch factor, so there's a variety of ways that they could not intersect, but don't be alarmed if you get no solutions. That can happen. If you get 1 point of intersection, they'll just touch in the one spot, and again, this could happen in a variety of ways. You might have it just touching like over here, they touch in one spot, something like that, but you could get them just touching at one spot. Or you may get the two quadratics completely intersect each other twice, and again, that could happen, both opening up, both opening down. Let's say you had the narrower one inside here. Well, they may cross over at two different places. So in both of these scenarios, you could get no points of intersection, 1 point or 2, no points of intersection, 1 point of intersection, or 2. All right, so let's take what we know. Obviously, you could use Desmos, type this into Desmos, and see where they cross. We're more interested in this section, though, of the algebraic skills needed to do this. Well, this one is set up beautifully for substitution. I've got p equals this and p equals this, so it's just a matter of replacing p, right, with what p equals. So p is equal to this, so I'm going to take my system, replace the letter p with 3k plus 1 is equal to 6k squared plus 10k minus 4. And now all of a sudden, imagine you're back in Unit 1. You just have to solve this equation. You look it over and say, oh, it's a quadratic. We have a skill set that hopefully should allow us to solve quadratics at this point. Move everything to one side. I always like to get my squared positive, so I'm going to leave it where it is. I'm going to move this over here, which will give me a plus 7k. Move this one over here, which will give me a minus 5. Now let's see if we can factor this. So your options now are solved by factoring. If it doesn't factor, you can always put it in the quadratic formula or use completing the square if you're more comfortable with that method, but the majority of you will probably go to the quadratic formula. So let's try factoring first though. 6 times negative 5 is negative 30. So we're trying to find two numbers that when we multiply them we get negative 30, and we add the same two numbers we will get a plus 7. Well, that is possible if we use 10 and 3. So positive 10 and a negative 3. 6k plus 10, 6k minus 3. So 10 times negative 3, there's your negative 30. 10 plus negative 3, there's your plus 7. This one will divide by 2, and this bracket will divide by 3. So our final factors would be 3k plus 5, 2k, take away 1, giving me two possible answers. So you have to say, well, what would make either of these brackets become 0? Now, many of you are doing this in your heads now, but I'll just calculate it for those that may still like to do this. So I'm just figuring out what would make the first bracket 0, and it would happen if k was negative 5/3. Now I'll go to the second bracket. So this is 2k equals 1, k equals a half. Now here's what students will do wrong. They'll say, okay, the answer is negative 5/3, comma, 1/2, that's not right, because these are both k values. Our answers should be an ordered pair of p and k. And in this case, alphabetical order would be k first, and then p. So I should be getting k comma p ordered pairs. This would be a k comma k. That's not an ordered pair when they're both the same coordinate. So what we have to do is find the p value when I know these two k values. So it's going to be two substitutions. So we're going to take the first one. Now unfortunately they're fractions, but such is life. Can't always control what kind of answers we get. P is equal to, again, you could use this equation, but obviously this one I think is a lot easier. Let's use that one. P is equal to 3k plus 1, because again, it doesn't matter. You're trying to get a p and a k value that work in both equations. Let's put negative 5/3 in here for k. So 3 times negative 5/3 plus 1 would give me negative 15 over 3. The number 1 is the same as 3 over 3. So in this case, I'd get negative 12 over 3, which is equal to negative 4. So this would be the ordered pair. Negative 5/3 would be the k value, and negative 4 would be the p value. Now we got to do the other one. So find p if k is equal to a half. So 3 times a half is 3 over 2. 1 is 2 over 2. So this would be 5 over 2. So the other ordered pair where these two graphs would intersect each other would be at the ordered pair k is a 1/2, and the p value would be 5/2. So this would be a scenario where if we were to put it into Desmos, I can tell from here that these two graphs, one's linear, so one was a line. This one's linear, it's a line, and this is a parabola. So this line and this parabola intersect each other in two different places. Okay, so let's look at a few more examples. So here's a system, linear quadratic. Let's take the linear one and rearrange it. So I'm going to just simply move my y to the other side. And now I'm going to substitute this into the other equation. So 2x squared plus 8x minus so instead of y, you always have to put this into a bracket. So instead of y, I'll just different colors so it stands out. Y is equal to this expression. So instead of the y, I put 4x plus 3. Now hopefully you see the importance of these brackets, because if you don't put the brackets, the negative's only going to go to here and not distribute through to both of these the way it should. Now I've got plus 3 equals 0. Again, beauty of this, I only have one unknown. So the new equation we've now got is 2x squared plus 4x. Now remember, this is going to be a minus 3 and then a plus 3, so that's actually going to give me 0. Those two are going to sum to give you 0. Minus 4x minus 3, that minus 3 and that plus 3 wipe each other out. This one should factor pretty easily, because if it's two terms, greatest common factor is usually or difference of squares. So this one's GCF. Take out your 2x. X plus 2 is equal to 0. I get two answers. X could be 0, or X could be negative 2. Take these, fill them in here to get the y values that go with each of these. So the y values, y would be 4 times your x value plus 3. So in this case, y is 3. So one point where these graphs intersect would be 0, 3. If x was negative 2, the y value would be 4 times negative 2 plus 3. So y would be negative 5. So the other pair where they cross would be at negative 2 and negative 5. So in this example, again, the graphs crossed twice. And this was another, oops, didn't want to do that. This was another example of linear, because there's no squared in it, so a line and a quadratic. So let's progress now to, I think I'll skip by these. I think that's pretty much straightforward. I think that would be enough. Let's progress to a quadratic situation. So now you got a quadratic and another quadratic. This one you could eliminate if you wanted. Just put a line underneath that, and let's add these. So I'd get 3x squared. 16 and 8 is 24x. Will eliminate the y's. Add these, I will get a negative 45. If I add those, it would be negative 45, correct. And now solve this equation. It's only got one unknown in it. It's got an x squared and an x, so it's quadratic. Set it equal to 0. Now again, notice all of these are divisible by 3. So because it's an equation, and as long as you divide the left side and right side all by the same thing, still be fine. And what that would do is make this a simple trinomial rather than a hard trinomial, which would make for an easier calculation. So now to solve this, multiply to get 15, add to give 8, 5 and 3. Now I would get x to be negative 5, or x could be a negative 3. To get your y values, now you're probably going to want to take one. This one looks, maybe this one I guess might be easier. Let's take y would equal, so I'm going to take that over there, x squared plus 8x. I move that there, and then I got to take the 19 over there. So I've actually not rearranged. So I just rearranged this one to get the y by itself. To get the y by itself, and I did that here. So why are you doing that? I'm doing that because once I know the x value, I need to figure out the y value, so I have to take one of the two equations and rearrange it. In this case, they were both quadratic. I guess this one I would say was a bit easier because maybe the numbers here were a bit smaller in front, but in theory it really doesn't matter. Pick one of the two equations. So now I'm going to put this answer to get my y value, put this in for x in this expression. So it'll be negative 5 squared plus 8 times negative 5 plus 19. 25, take away 40, plus 19, 25, so y is going to be 4. So negative 5 comma 4. There's one point of intersection. Get y. Substitute negative 3 in for x. So negative 3, so x squared plus 8 times negative 3 plus 19. So this is going to be 9. Take away 24 plus 19. 19 and 9 is 28. Take away 4 is 4. So the y value is 4 for this one as well. So the other point of intersection is at negative 3 and 4. 2 points of intersection. All right, let's pick maybe one more. So here's another quadratic. Now this one's set up pretty nicely because it's got y equals and y equals. So I'm just going to simply replace this y with what the y equals from up here. So I'm going to go x plus 2 squared minus 1 equals x squared. Take away 4x minus 5. So what I really like about this section is we're not really learning anything new other than taking things we've already learned and just using them as the tools to solve the system. To solve this, I'm going to want to expand this side out. So x squared plus 4x plus 4 minus 1 equals x squared minus 4x minus 5. Move everything to make it equal to 0, which is also going to be very nice because when I move this, let's say I go everything left, x squared minus x squared, they're going to be gone. So I'm going to have x squared plus 4x, this is going to be plus 3. This is going to move over and become minus x squared, this will become plus 4x plus 5 equals 0. Well, that gets rid of that. 4x plus 4x is 8x plus 8 equals 0. So now I can switch gears and say, oh, this is linear now. And rather than getting it equal to 0, I'm going to take the number to the other side and isolate the variable. And that is going to give me x is equal to negative 1. So this time I only got one point of intersection, which we know can happen. So you say, well, how am I going to get the y value? Well, find the easiest one you can. Really no difference here. Let's take the top one. X plus 2 squared minus 1. So y is x plus 2 squared minus 1. Take your x, fill it in here to get your y value. Negative 1 plus 2 squared minus 1. So that's 1 squared, which is 1, minus 1 is 0. So these two quadratics intersect at the ordered pair negative 1 comma 0. And like I said in the earlier video on linear, you could easily be typing these into Desmos. Type this in, and visually you would see that the two parabolas would intersect at the one-ordered pair, negative 1 and 0. And that's it. So there's how you solve systems of equations that involve quadratics. So we looked at both a linear and a quadratic, and we've also now in the last couple looked at two quadratic functions and seeing where they crossed. But as I think you would agree, it's really nothing more than using the skills you had already acquired starting back in NERF 10. Alright, so now you can do some practice from your textbook. There's some good questions in your textbook on solving linear quadratic and quadratic systems. Once you finish those and feel confident, there is a formative involving section 4.3a and b that you could use to then make sure that you do have a good handle on this information. Alright, so thanks for watching. As always, if you run into any problems, reach out via Teams and I'll see if I can get you pointed in the right direction. Thank you.